Imagine stirring a cup of coffee. You see the liquid swirl, creating a tiny whirlpool in the center. Now what if I told you that the universe does something similar but on a much grander scale? It's not coffee being stirred, but the very fabric of space and time itself. This might sound like science fiction, but it's one of the most mind-bending predictions of modern physics. Massive objects like planets, stars, and especially black holes don't just sit in space. When they spin, they grab hold of the universe around them and twist it. They create a cosmic whirlpool, not of liquid, but of reality itself. This is a universe that is far stranger and more dynamic than we ever imagined. This twisting of space-time is a phenomenon known as frame dragging. It's a core prediction of Albert Einstein's theory of general relativity, yet it's so bizarre that even he had trouble fully accepting its implications. Instead, space and time are connected into a single flexible fabric. When Albert Einstein published his theory of general relativity in 1915, he rewrote our understanding of gravity. A planet, for example, creates a dip in this fabric, much like a bowling ball on a trampoline. Other objects, like moons or satellites, simply follow these curves as they travel. A few years later, in 1918, two Austrian physicists, Josef Lenzer and Hans Thirring, explored what would happen if the massive object, the bowling ball on the trampoline, was also spinning. Their calculations revealed something astonishing. Its rotation would actively drag space-time around with it. Before we can understand how space-time gets twisted, we first need to grasp what it actually is. For most of human history, we thought of space and time as two completely separate things. Space was the three-dimensional stage. But then, Albert Einstein came along. Instead, they are woven together into a single four-dimensional fabric. When you arrange to meet a friend, to define an event in space-time, once Einstein had established the concept of space-time, instead, it was flexible, of a bowling ball on a rubber sheet or a trampoline. The sheet stretches and sags. This is precisely how our solar system works. The Earth and other planets are simply following the straightest possible path through this curved space-time. Even light, which has no mass, is affected. This effect, called gravitational lensing, Einstein's general relativity gave us a universe where mass tells space-time how to curve. But the theory also says that motion and energy contribute to this curvature. In 1918, Lenzer and Thirring took Einstein's equations and asked a simple but profound question. Their calculations showed that a spinning object does something more, and drags it around, creating a swirl or a twist. This is frame dragging in a nutshell. Think of it like trying to cross a river with a strong current. In the same way, the current of space-time created by a spinning object. These are the domains of spinning black holes. It takes the twisting of space-time to a whole new level of weirdness, known as the ergosphere, until at a certain point it exceeds the speed of light, so you are forced to rotate along with the black hole. You are caught in an inescapable whirlpool of reality. In the 1990s, a team of researchers led by Ignazio Ciufolini decided to use two laser-ranging satellites, Lagios and Lagios 2. Scientists on Earth bounce lasers off them to track their positions with incredible accuracy. The quest for definitive proof. It was called Gravity Probe B. The gyroscopes had to be perfect. Essentially a giant thermos flask called a dewa, the satellite was launched in 2004. For 17 months it flew. Finally, in May 2011, after years of meticulous data analysis, the result was a stunning confirmation of Einstein's theory. Consider the network of satellites that form the Global Positioning System, or GPS. So, the next time you use your phone to navigate to a new restaurant, can launch colossal jets of plasma, converts the immense rotational energy of the black hole into tightly focused outward-bound jets of particles. Our journey through the cosmos has brought us face to face with one of the most profound and mind-altering ideas in all of science. The universe is not a static place. It can also be grabbed, twisted, and set into motion. A cosmic ocean where massive spinning objects create swirling whirlpools in the very fabric of existence is a testament to the power of human intellect and persistence. Ultimately, the confirmation of frame dragging leaves us with a sense of profound wonder, touching every aspect of our cosmic understanding. It is a universe where nothing exists in true isolation. About the mysteries that still lie ahead, it is a victory for human curiosity. The universe is waiting to reveal its secrets, one magnificent twist at a time.